HTML5 in general naturally supports real-time web, right? And as you all mentioned before, they do it through WebSockets. So I put some WebSocket servers that you can download online. Like there's some that are free, open source, you can get. Others you can purchase with support. Or if you're really interested, you can code your own. Again, it's not that difficult. So there are a lot of options out there. Right? Again, this is specific to the scenario or where we need to send like a... Anyways, I'll repeat again. My name is Derrick, and I'm doing an interactive session today on architecting public-facing website software for a high concurrent user load. So in that sense, I want to emphasize the word interactive. I'm hoping to have a discussion with you about the subject matter on these slides. I don't want to stand here sounding like a preacher, just preaching the gospel to you sort of thing, right? So that being said, I'm just curious, how many of you are involved in your company's public websites, like web developers? And okay, so that's let's see, 1, 2, 3, 4, 5. So the vast majority of you're working in the more like the application space, right? Not like on real-time embedded software or anything. Okay. I was just asking because usually in the SEI, their material is mostly focused on real-time embedded software. So, okay. Also, because of the wide range of topics under this, I'm just only going to focus on a few things that I think are important and that what I've learned. And also, from going over my material, I think that some of this work here could also be applied to just enterprise architecture as a whole, simply because nowadays most enterprise applications also use a website front end like WorkBrain or SharePoint for that matter. But things inside the company don't really experience the amount of user load as public-facing applications, right? Like you're not normally going to hire the same number of employees as you would find in using the public web, right? So that's why the focus will be on public-facing websites. Let me check. Now, last but not least, I just want to remind everyone, this session is being recorded, so depending on the topic of the slide, you may want to choose some discretion in what you disclose, right? Yeah, actually, that would. Because of some of the subject matter on these slides, I would suggest, and the fact that the session is being recorded, I would ask that perhaps I would suggest that you maybe exercise some discretion on what details you disclose, right? For example, like your employer name and so forth.
2, 2, 1, 2, 2, 2, 2, 2, 2.
So, can everyone hear me? Okay. Anyways, I want to talk to you first about how I got into this, interested in this challenge. So, it goes really back to early 2011 when I joined my current employer. And there, at that time, I was actually responsible for their public-facing websites. And what happened in July of that year was that there was an incident, there was a death that impacted one of the services my employer provided. And that news hit the general media. So it was on the newspapers' websites as well as like TV and radio. So when that news hit, our customers became concerned because a lot of them relied on our services in order to commute back and forth from home and work. So they began checking our public websites to find out whether they would have a way home or not, right? Because they didn't know, well, if the service was canceled for the rest of the day, they got to make their own arrangements. So that spike in user load, we believe, caused what we noticed was a serious website performance degradation. So pages weren't loading up in the regular 3 to 5 second range. They were taking maybe 5 minutes or sometimes just timing out altogether. So after that fateful day, we regrouped and as per typical IT departments, we did our post-mortem analyses, and we came to the conclusion that it was the high user load that caused the issue. But we wanted to be sure. We wanted to double-check our assumptions. So what we did was we contacted an external load testing vendor, and I worked with that vendor to develop a series of load test scenarios that we felt simulated exactly what happened that fateful day. So then, once we agreed on the test plan, the vendor executed the load tests, and they came to the conclusion, based on their research, that bandwidth, specifically with the pipe connecting our DMZ to the internet, was the issue. So I just want you to remember this, because I'm going to speak more about it later. Hi, yes.
So you did load testing on production?
Yes, we did it obviously in the early morning hours, right? So it wouldn't impact the public users.
This is a US only site?
No, it's in a different. It was in Canada, so yeah. No, not global. Yeah, so it's mostly the load comes mostly from people in the same geographic region, right? Because it's a commuter service, so.
Were they just completely external as load testing program, or did they actually come into your data center?
They're completely external. So yeah, they have a cloud systems to simulate load from different geographical locations, right? So in that sense, it was a good test.
How they knew, how they would know whereabouts in your infrastructure problem would be then if they were completely external, so perhaps you can talk about that.
Yeah, they did some. What happened was they had measuring software inside, and they noticed that when they're doing the load test against our servers, they noticed that the CPU usage and the memory usage was rather light.
Right. So you gave them other information.
Yeah, so from there, and then also our vendor, right, that managed the data center was able to give us the network traffic. And from there, that's how they determined it, right?
Did you
Yes?
notice the same degradation in your pre-production environments?
Okay, that's a good question, because we're pretty primitive right now. So at that time, there wasn't really a pre-production. There was development and test, which is one environment, and then there's production. And because that development test environment is all in-house, we really couldn't do a meaningful load test against it. Additionally, so with the bandwidth thing assumed to be the issue, we had some takeaways, and some people went and researched that. But additionally, I just want to mention that we also have several public-facing applications. Most of them are based on the REST architectural style. And those also, we noticed, experienced performance issues under high user load. So these type of problems plagued us from time to time over the past few years, and as recent as February 2015. So all that data was all collected in our problem incident reports. And I went through those reports, did some analyses, and came to some conclusions, which I will talk about with you later on. Okay?
Are you able to say roughly what scale we're talking about?
In terms of scale as what?
QPS.
Sorry?
Actual request rate.
Actual request rate?
Per second.
Per second?
Number of concurrent users?
I mean,
Order of magnitude would be good.
yeah, in terms of number of concurrent users, we're looking maybe about, based on what we see, could be about maybe 50,000 to 60,000, around that range.
So you could have like 60,000 parallel requests at one given point?
Yeah, I believe so. If I have to go back to my logs and check, though. That's a good question. I don't remember because it was back about several years ago for me. But because we are, now that I think about it, because we are a regional business, most of the user load is coming from the same geographic region. So it's not going to be that like, not in the same scale as some websites like CNN, for example, right? Where they will have probably millions of concurrent users, but spread across the whole US. So one thing is, a good question is, am I the only one experiencing this issue? Well, apparently not, right? So if you look at the media, you'll see that the other public-facing websites also had issues when dealing with sudden spikes in load that they didn't anticipate. So the first link I think is pretty interesting because there it shows that Coca-Cola also has similar issues, which I found surprising because Coca-Cola probably has a bigger IT budget than we or us. And also nowadays, you have social media and the Internet of Things. So everybody with their mobile devices are all online, right? So if you're experiencing problems with your public-facing websites, you can expect also the news to spread pretty quickly, even at a grassroots level. So I put some social media tweets I found about a recent public website performance issue online. I thought it was pretty interesting and pretty funny, too. But as you can see, there can be some negative publicity dealing with public website performance issues. So it's a good thing to keep it in mind when you're architecting your own public-facing websites. So that being said, is this a new problem? Well, actually, before I go that, how many of you have experienced similar issues with your public-facing websites? Interesting. But I guess it's all due to load you didn't anticipate, right? Like a sudden spike, or yeah, usually is the case. But anyways, we're not alone, and this problem has actually been around for a very long time. So it was. You look at the title here. This person, Dan Kegel, he actually looked at this problem way back in 1999. And then he called it the C10K problem because his theory was that at that time, in 1999, you could support 10,000 concurrent users on a single web server built on reasonable hardware. Okay. Because back in 1999, 10,000 people was quite a bit, right? Yes?
In 1999, much of the web content was static too.
Yeah.
It's kind of different. This is like an Apache scenario, which is sort of static content.
Exactly.
Things are quite different right now.
Yeah, and it's evolved. And actually, it goes into that on his website to some detail. Primarily, if you look, like, the C10K problem is probably well known. You've all heard of it already, right? So, oh, no? Oh, I thought it was well known because I hear it mentioned all the time. But anyways, the thing is, he did his research, and he came up with a set of architectural best practices and strategies that you could use to write your own web server. Well, so nowadays, all the web servers you have out there, like, for example, Microsoft IIS, they all contain Dan Kegel's architectural recommendations. So he's pretty well solved the problem there. And since this information is all online, I don't really want to spend too much time yapping about it, because you can read about it online. But what I did was I prepared a little flyer that I'd like to pass out to you about the C10K problem. So it'll have the links that you can actually go and research and read his work. And you can also include, I put links about how it has evolved. So if you can see the second point, like you said before, back then the web was very RESTful, right? Request, response, that's it. Static content, right? But it's evolved now. We have more dynamic things. And that work, people have already been looking at that side of the dealing with high concurrent user load. And they've even evolved a problem. They call it the C1 million problem. And they have solutions as well. So I put links to that in this flyer here. So I'll pass it out now. I guess you're the lucky one. You get the color one. I apologize for the black and white. What happened was I originally planned to come down here to do the copies. So when I made that plan, I didn't realize there would be some things going on the streets. So last night when I arrived and tried to, actually do the copies, by the time I reached FedEx, they were already shut down. So I had to do black and whites here. Let's see. I think we have more than enough for everyone. And let's try this. Okay, thank you. There you go. Now, when you actually read Dan Kegel's website, thank you. There should maybe an extra one slipped in there. You'll notice that a lot of his work, again, is primarily focused, well, all of his work is primarily focused on how to code a web server. Maybe, sorry, I don't have enough copies of the flyer. OK, I'm sorry, I don't have enough copies of the flyer on hand. But please leave your contact information with me before you go. No, I certainly want to keep in touch with all of you and maybe learn from your experiences as well. Maybe we can work together offline after this session, share best practices, architectural ideas, and maybe come up with our own strategies for how to deal with this challenge. But I'll also be able to email you a PDF or a Microsoft Publisher copy of the flyer so that you can print out on your own. But what was I going to say? Although Dan Kegel's work is primarily focused and only relevant to coding the web server, there's some principles in there that you can use and apply to your application code. Like obviously, you're not going to do asynchronous I/O programming when you're writing your website applications, right? You already have your frameworks. Probably you're doing it on top of what? Java or .NET to do, right? But there's some principle like asynchronous communication that can be applied. And then some other websites have applied it already. Now, since Dan Kegel's already solved the problem in the web server, I'll assume everything from ground up to that point we don't have to worry about. So I'm going to focus on the things we control, basically the application code, right? Because every public website out there is going to be unique depending on the organization, right? They have their own brand and therefore their own features that we have to code. So in that sense, what are the main things in the application side we can control? Well, I basically boiled it down to 4 topics that I'll talk about today. The first piece we control is the Web Content Management, or WCM. The second, and probably the biggest control we have, is with the actual dynamic online features we code, right? Because we write it ourselves. So we can choose how we architect that easily. Security, that doesn't really have that big of an impact on website performance. But there's some nuances with modern security practices to be aware of. So I want to touch on it briefly. And infrastructure hosting, well, obviously back in, I guess in most of our days, we all come from, I guess, the on-premise type of background, right? But nowadays, there's a lot more hosting options out there, which I want to cover. Yeah?
About security, like, we've had issues with security appliances, like specifically intrusion protection systems.
The IDP, OK.
Certain points get triggered, they go in deep analysis modes, and then basically wreak havoc on performance.
Oh, as a bottleneck or something.
Yeah.
OK, interesting.
Same thing with web application firewalls, depending on the rules that are configured and substantial additional latency.
Yeah, I guess you can, but it also depends how many you have in there, right, and how you scale out and stuff. Like you can have more than one IDP, right, in your system, right? So, yeah. Now, I deliberately left out one thing that actually has an impact on performance. And do you know can you guess what that is? Down here?
I think the major bottleneck is data store, right?
Yeah, basically the information architecture. I left it out because that's basically a huge topic on its own, and probably we won't have enough time to talk about it in this time. Right, so like, as part of some, if you have web pages that have to make a callback to get information from a data store, like even a basic relational database, then the schema really can impact performance because that codes how you write your queries, like how many joins you have in it, and that can slow things down. So the first piece I'll talk about is Web Content Management, or WCM. Now, I just call it that because that's the term I grew up with. But I think nowadays they've renamed it the vendors that sell these systems call it Web Experience Management or Customer Experience Management. Right? They want to show that their systems cover all the digital channels, not just the traditional desktop browser, but also mobile. So does everyone know what WCM is? Oh, OK. Well, I was going to talk about it briefly anyways. But essentially, a WCM solution is a repository that will hold page templates that will dictate the look and feel of your website. Additionally, it'll hold all the content that fills those templates. And by content, I mean text. So it'll have, depending on the number of languages you support, you'll have English text, French text, German text, even kanji languages like Urdu text, Japanese text. Right? You'll also have images and other digital assets as well, such as sound bites or video clips. Whatever you want to put online, you put it in your WCM system. So in that sense, it's very neat because it separates your content from your functionality, right? So authors and editors can go edit the content while you work on the actual features. They're quite widespread now, so I'm actually surprised. I thought all of you would have used these systems. Like, are any of you using Drupal in your websites or?
Gem.
Pardon?
Gem.
Sorry, how do I?
Similar to Drupal, it's Python also.
OK, yeah. So that's a typical WCM system. Now, even if you don't think you are, you probably do have a WCM system in your house. Because nowadays, most organizations purchase enterprise content management. It's a pretty widespread, commoditized product. And usually, WCM comes with that. So if you have a document management system in there or a records management system, it probably has part of the whole solution suite. It probably has a WCM component as well. You just have to ask for it. That's all. That's just as an aside. But today, I'm only going to focus on the one aspect of these systems that have an impact on how your websites handle the high concurrent user load. And that's what I call the content delivery architecture. Right? It's basically how we get the web page in front of the public user. And there's only two types, page-based or decoupled. So no matter what WCM system you choose to purchase, they'll only fall into one of those two buckets. Okay? So I'm now going to define each one so that we are all talking the same language. So in a page-based system, it works very similar to the traditional internet. You'll have your public user with their internet browser on whatever device, be it PC or mobile. What happens is, let's say they want to view a web page on your website. So they'll just make an HTTP request to a web server on the web presentation tier, right? And then from there, that server will make a request for the latest approved content from the WCM store behind it. That system then puts together the content and the template into a page that it returns to the web server, which then sends the user understandable page back in HTTP response to the public. So what's the big deal, right? Very typical web behavior. But what happens under high concurrent user load? So I try to take away the technology from it because I want just to show the concept. So you think of this as in terms of territories the public has to cross to get their content. With the outside being the internet, you see the first step is from the outside they have to make an HTTP request to the web server. So that's one boundary to get through, they have to go through. The next is then they have to go from the web server to the WCM store behind it in order to get their content. And then it has to be passed through those same boundaries again to get back out to the end user. So in a high concurrent user scenario, you have the possibility of each HTTP request from the outside becoming a content request to your WCM store. So in this scenario, you will have to consider and ensure that you architect your WCM portion so that it too can handle the high concurrent user load. Now, there are ways of doing this. There's caching, so where you cache the pages that the users frequent the most on your web servers. And that will reduce some of the traffic inbound to the WCM portion. But there's a trade-off, right? Like caching is not the easiest thing to code. Right? We know it's one of the challenges. Cache invalidation is one of the big software engineering challenges. But also, it's not entirely reliable either because you have the problem of, well, you don't know how the user is going to behave each time. They may all be looking for one page one day. The other day, they'd be looking for another, right? So you have to plan for those as well. Now, additionally, there's one other aspect I want to point out too, is that here, what's happening inside in your WCM solution? Well, your authors and editors in your company are editing and updating content, right, to be presented to the public. So if you have a high load on your public websites in this page-based scenario, then there's a possibility it's going to impact the WCM solution, and therefore your internal authors as well may feel the slowness when they're trying to update and publish urgent content like breaking news whatsoever. Okay, any questions so far? Okay, yeah?
Some scenarios, edge caching might be useful.
Yeah.
Like
Yeah, I've seen people use like memcache and stuff like that.
edge caching.
Yeah, edge.
Outside of your own infrastructure.
Yeah, I'll actually go into that later too. That's actually a good point. So what's the other bucket? The other is the decoupled content delivery architecture. And in this, what happens is, okay, I'm just going to cross this other side here. You have your authors and editors working on the content here inside on the WCM solution. And when they're done, they'll probably put the content through some type of workflow for approvals. And when that's done, the WCM system will put the content and page templates together to make the updated web pages. And they will physically publish them to the web presentation tier. So by physically publish, I mean copy the files over. So there'll be some type of FTP usually that happens. And the files will be static pages here on your, in your web server. So in that sense, every time people from the outside browse your web server, for sure they're going to get the latest approved content. So in this scenario, if we look at it using the same type of conceptual diagram as previous, you'll see at the edge, the user load is basically from the public remains at the edge. So the WCM solution doesn't have to worry about it. And content's pushed out from the WCM to the web server. So in this scenario, only your web server tier has to be architected to handle the high concurrent user load, which is easier. And also your internal authors won't have to worry about it. And your WCM system doesn't have to be architected for high concurrent user load. So how do we determine the difference? What's decoupled, what's page-based? Well, most are page-based. In my own research, I only found there's 3 I know of, for sure. So the first, Ingenix, that's just a small company in, I think it's somewhere in Seattle. So they're pretty new. You probably haven't heard of them. The second decoupled one, SDL Tridion, you probably heard of them. They're based in the UK. And I believe they are in the Magic Quadrant for WCM systems in those Forrester and Gartner research reports. So they're very big. They're a well-known vendor. The last one, the EMC Interactive Delivery Services, I know that just because I worked on it in a previous life. But essentially, this last piece is nothing more than the FTP publish portion. So it's not really as full-featured a WCM solution as the first 2. So it won't have all the neat features like analytics and whatnot in it, or responsive design, things like that. It's very bare bones. So you probably want one of the first 2. The other one that I heard was decoupled, but I haven't been able to verify for myself, is a HP interwoven. So that's another choice. Yes?
The Electron content management system is also decoupled.
Electron, okay, yeah. Okay, I didn't know that. Okay, thank you. So you've used Electron before. Okay. You like it?
I think Vignette is also decoupled in a different way.
Yeah. They have, the last architecture I saw from OpenText, when I asked them about this, was that they published their content out, but to a database server. And what they showed me was they published it to a database server in their DMZ, and then the website goes to that database server for the text content, right? And then the other images and stuff, I think, are actually copied over to the web server. So there's some split. So it's not pure decoupled, but it's getting there.
Derrick,
Yeah.
when it is decoupled, so it basically means that the content is static then? There's no interaction with the user that goes all the way to the data store?
Yeah, there's no essentially content is static. There's no interaction with the user going to the data store. So that's a trade-off right there. But for most text content on the web page, it doesn't change that often, right? So those you can just naturally belong in the WCM solution, right? So it doesn't hurt to have it decoupled because you're only going to do the FTP once a day at most, right? Or a couple of days. Yep. Sorry, do you have more follow-up?
Okay, so this is the scope of the talk for those kind of use cases?
Yeah, that's the scope. Exactly. Yeah, that's a good point. Yeah.
Are you going to speak to the use case of personalization even on that content that's pushed out to the, I don't know what you called it, out to the edge basically, out to the web server, where you would still have a personalized system or personalized content and that sort of thing?
I will speak to that a little later. But there those scenarios, I'm mostly concerned about, in terms of personalized content, those that you have to check back to some back-end system because you only discover the user's identity after they log in, right, to identity management. And they'll return the information from the back-end system to them. So, but I will talk about that. And that's the next topic, right?
Okay.
So, but also in a very specific sense, right? So again, like if you're getting a ECM solution, they'll probably have a WCM solution included with it. So when you're purchasing that, you will probably want to keep in mind you want to have a decoupled one included with that solution, like Electron or stuff. It just makes it easier because when it's all bought together, you have all the connectors in place, so you can have a very smooth flow of content from anywhere in your organization out to the public web. So now on to the next part, which is more like what you were talking about in terms of more personalized content. So this, I just put it in as architecting online features, where the content is more dynamic. Now, there's really, for the sake of this talk, I'm just going to look at 2 buckets, really, of features. First, there's those that don't require callbacks to a back-end information system, like some type of single-player Flash applet game, right? Those under high concurrent user load, while each of those applets all run individually in each browser, so it doesn't matter. There's nothing we can do about it, and it's spread out anyway, so there's nothing to worry about. The ones I think we do worry about, and like to your example of personalized content, if it has to call back and get information from a CR back-end customer relationship management system. Let's say somebody logs in with their profile. They want to make updates to their account on your website. Those have the possibility of passing user load then from the website back down to back-end systems. So we'll look at those specifically and how those are implemented. So the most popular way of implementing them, I think everyone knows, is sort of like the RESTful style, right? Everybody knows what REST is, right? It's just basically the way the traditional internet works. Make a request and get a response. It's stateless, so forth. So it's very easy to code. And it's very good. It's one of my favorite ways of doing things. But what happens during high concurrent user load, right? Because that's what we're concerned about here. So this person had some experience. They only used it internally, right? But they showed that their implementation details you have to be careful of when you're implementing RESTful architecture. So again, it's our own custom code, right? It's things we can control to help. So what he found out was he ran into his issues is because, first of all, he made RESTful methods that returned fat messages. That's probably because it's stateless, so he wanted to get all the information out to the end user. But as we saw in the previous slide, bandwidth is something we have to watch. So if you have a large response message, and I've seen some methods in the past that returned a message about 1 megabyte in size, it can take up a lot of bandwidth, right? So it's just something to be careful of. Again, it's something we can control, what we implement, right? The other thing is, again, he architected his so that he had sort of like several REST components all doing different things, and they had to work together to get the information the user wanted. So in the HTTP request response model, it was like a cascading tree going down several components to get to the information source, right? So going through all those components took time, and that slowed things down for him. And again, that's something we can control, right? Yes?
Those two things have nothing to do with REST, right?
Yeah, it's more his. They have the
It's
some.
nothing to REST that forces you to have.
Yeah, it's more of a behavior. Yeah, exactly. He. Yeah. Yeah, he chose to do it that way. But so this is something I found out too. Some people implement it that way, and it's not the most efficient. So I wanted to just highlight that.
I think to his point, you'd have the same problem if you used just about any other technology.
Yeah. Yeah, it doesn't matter. Any other technology is the same thing, exactly. So that is not really, it's just that's not something we should do when we're doing it. That's all, just to be aware. But even then, like if you're only calling it once in a while, let's say you just one time go pull up a personal profile, that's not a big deal, right? That's not a lot of load. It's really only in the situations where you have, let's say, if you're using a system to provide breaking news or urgent updates to the end user. So let's say you have an event, let's say like a death or something that impacts your service. You want to alert everyone right away, send out an alert. If you use REST, then it becomes interesting, because how do you keep people updated in a RESTful system? Well, because it's request response, right? You have to have some type of loop in your web page, right? Some type of timer or so that every 5 minutes you call this RESTful service to check for updated information, correct? Right? So what happens in that scenario? Oh, I forgot I can use this. So I choose to look at it in a very simple, I use some AADL boxes because I think it shows it nicely. For the communication, I chose the event data port simply because they can represent these service calls as well. Not exactly, but at least it'll show the direction to which the messages travel. But in the process boxes, because each piece can be considered a process. But in this scenario where you have a loop, right, where you're checking every 5 minutes, what usually happens is your web browser will make an AJAX call on that frequency out on like every 5 minutes to some RESTful service, right? And that service will check probably some information system in the backend, like a database, whatever. And then that'll return the response to your RESTful service and then back to the web browser. So it's okay, again, if it happens once. But in this particular scenario that we're focused on, it's happening every 5 minutes or even possibly every 5 seconds. So you have a high number of concurrent users. That's a lot of traffic, yes?
So why are you polling?
Polling? Oh, because you want to give the user the latest information.
So why not push?
I'll get to that. Yeah, that's a good point. I'll get to that later. Right? I just wanted to show why I recommend push as opposed to this polling thing. Right? So I just want to go through to give you the why, right? Just to get us to think. So in my own experimentation, the first way I tried, I did it with a lot of different components, each polling each other. As you can see, when the concurrent user load increased, I also had an increase in response times as well. Now, this is not bad, right? Because this is in the scale of milliseconds. So it's still okay. It's pretty responsive. No, it's not bad.
40 seconds?
Yeah. Yeah, but at this point here only. Yeah. It depends on requirement stuff. But again, I changed the implementation a bit. Scaled down the size of the messages and the number of RESTful components, and I was able to get something more logarithmic, right? So I just want to do this just to show you that, again, it's nothing, like you said, it's nothing to do with REST, right? It's just the way we implement it. So let's be cautious if you're doing it like by polling a RESTful service. The last technique I tried, and I just, again, from a Kim's suggestion, was sort of a push thing, right? So there I found I had the best response times versus concurrent user load. But again, it's not really apples to apples comparison because with the push, I'm keeping track of state, right? So I know what I sent last time, so I can make my messages smaller as well, right? And it's a different architectural style too. So
What happens when you have a high event load with push?
yeah, then it's, again, there's some graphs on that on the web too. Again, of course, it's going to slow things down, right? So you have to be able to scale out. Again, it's the way you implement it. Yeah, that's a good point.
The challenge with push, I think, is you have to keep typically TCP connection open.
Yeah, exactly.
A large number of connections.
Yeah,
That can be challenging.
exactly. That's the trade-off. The state, maintaining state, right? So that's something to be aware of too. So let's summarize what we just talked about. And the buzzword I was able to find for is real-time web. And I say that loosely because, web cannot be real-time, right? It's just that a lot of marketing people use that adjective. But there is an actual definition that someone tried to put on Wikipedia, their own opinion, which I will show you.
Polling connections open on the node servers, no problem. So you can have,
Yeah.
and you have millions of connections
Yeah,
at one time.
Yeah, so there's some firewalls, for example, that have to support all those connections.
Yeah. It's all trade-offs. Exactly. It's all trade-offs. It's a good point. So this is the online definition of real-time web. And what they described is using a style that the user receives the information as soon as it's published by its authors, and that it does not require the polling, as you can see from the last statement. Now, I wanted to show you this because you notice how the definition is actually pretty vague, right? It doesn't tell me. And there's no quantitative thing. It doesn't say they have to receive the information within 10 milliseconds or whatever, right? or how many concurrent users have to experience this behavior. And it's on purpose, because we can't control what happens on the web. We can control what happens to some extent within our own corporate networks, right? But outside on the web, you just never know who's going to do what.
Actually, I work with Sony for the
Yeah.
PlayStation Network, and we have a service which is basically streaming gaming,
Yeah.
which goes over the internet, and it's really good. I mean,
Yeah.
a lot of people are accepting that can be done over the internet.
Yeah.
But it's,
Yeah, it can be done.
surprisingly well.
Yeah, true. It's true. It works surprisingly well, but
But it really
it's not
depends
perfect.
what the user wants, right? I
Yeah.
work for financial industry, and every time they want price changes stocks, they want it real time.
Yeah,
Real time on their perspective is always different, because if a
True.
price changes 1,000 times a second, it's not going to get time to do anything.
yeah,
And if it's a web browser, they're not going to take any decision or do anything with the price changes so much.
yeah, exactly.
So then what I do is I try to understand what they're going to do with that information, and based on that, we decide how much of a real time is real time for them.
Yeah,
Well, for them,
exactly.
real time is faster than the other trader.
That's an interesting
As
definition.
soon as the other trader can get it faster, he's not happy anymore.
It doesn't matter if it was 2 hours later.
Yeah, very true. Make sure customers get it first, right? So let's go back to this. So to show the behavior and just to see the difference from the polling feature, I did it as a very simple UML sequence diagram. And because I mostly use Microsoft technologies now, I use that as the example. But essentially, for the updates, as you can see, you're just sending, the information just flows out, right? It starts from the author inside, they make an updated database that pushes out to some push hub that pushes it out to the web page. Easier said, but so are all of you familiar with these push technologies, how they work and all that? Or okay, you know what? Maybe I'll show the demo anyways. I prepared a quick demo just to make sure that we understand what I'm talking about, that we're all on the same page. So I'm gonna hang on a second. See if it's still alive. I came here late, well, not late last night, but last evening to set this up on the laptop that they took away, so I had to set up again this morning. But to let me so in the top page here, you'll see what the authors will use, so what your internal users will be running. It basically lets them send a message, and the bottom page is what the public will see, right? So to demonstrate it, let's say they have some breaking news. They want to alert everyone. Maybe there was a death or something like that, or some protest coming your way. So you type it in and then hit send, and then you'll see it'll just appear on the public page. It took a little bit of time, right? It wasn't under a second. I think that's about a second and a half. I wasn't timing it. But you see, so again, because like you said before, there's some overhead, right? Establishing, tracking state, establishing the connection. I think that's took the first time.
You're using WebSockets, just card.
Yeah, this I think is using WebSockets. The actual framework I used, I'll show you the source, just to prove to you I'm not pulling anything. What's taking so? Oh, okay. Sorry, I have it on the wrong. So you look at the source. Oh, it's not. if you look at the source here, I'm going to page down. Okay. I used the Microsoft framework just because it's the one I'm most familiar with. Sorry about that. But as you can see, all it's doing, usually the signal R, it picks the WebSockets first. And this is the latest IE, so it's using WebSocket now. But essentially, it's just making a connection. Like I said before, it's incurring that state overhead to make the connection to the push hub, and it just waits for a message to come across. That's it, right? So it meets the definition on that Wikipedia page of real-time web.
Question for you.
Yeah, sure.
So with the real-time web and you're holding a socket connection open and things like that, what's the impact on things like load balancers and things like that?
Well, this one's taking a while too. Well, that's a good question. Like, if you're holding a connection open, like, I guess you'll still have the connection going through. The load balancer will have to hold it too, right? So
is it virtually open? I mean, with a pulling mechanism underneath, or is it literally held open?
I think it's literally held open. There's no pulling underneath. So again, there's a trade-off, right? There's a trade-off. So the second time too, I don't know why it took a little bit of time. That's about a few seconds, but see. But afterwards now, I think, because the connection's established, as you see when you press the send button, it's just in an order of milliseconds it comes across. Okay? So in addition to using this, not using the polling and therefore using less bandwidth, you have a very nice user experience as well, right? So for end user, it's more dynamic, more interactive. And just to highlight again, if you look, I made another sort of AADL diagram showing the same processes, but this time for real-time web. And here, as you see for the updates, you're only having the message going out, so you have less traffic going in, right? If you compare this to the previous one I had here, sorry, I passed by it. This one has the messages going in as well. Each time there's a request for an update. But here, because you're doing push, it's just going out. So you lose. So there are some things we can do in our code to help reduce, right, the amount of bandwidth we use. So who uses real-time web, these push techniques? Well, actually, it's been around for a while, several years now. And I put these three examples on purpose, the Twitter, the Facebook, and the Google. And there's a reason for that, because they're, unlike probably most of us, they will experience a high amount of concurrent user load regularly. So it's not like once in a while they get a spike. They get the traffic all the time. Now, that being said, I'm just curious, for the person that, for the PlayStation gaming thing, right? How much is I guess your user load is high usually on the evenings, or? I guess.
So we're a global operation.
Okay.
So we've got lots of customers in Europe, quite a few in Asia. So our load never goes really down a lot, but it's like a sign a bit, and I think our peak is around midday in California. And
Yeah.
hours later we have control.
Yeah. I guess it depends when people in each geographic region are actually playing the games, right? So, yeah.
Typically late in the evening.
Yeah.
And then you can like aggregate all the different regions.
Yeah. Well, that's good. At least they're not playing video games during the day at school or at work, right? So, anyways, let's thank you. That's very interesting. So what are some examples of these frameworks? I obviously talked about the Signal R. I think that's the one I'm most familiar with. But there's other ones out there too, like Comet D. There's some Ajax push engine too. I put a link to this article I wrote for MSDN Magazine. Basically, it's just a real-time push using Ajax long polling, or reverse Ajax, they call it. I just put it there so that when you see it, it's actually not difficult to implement these type of systems. If I can do it, pretty well anyone can, because I'm not a smart person. So, last thing I put, HTML5 server-sent events. That's just one way, but HTML5 in general naturally supports real-time web, right? And as you all mentioned before, they do it through web sockets. So I put some WebSocket servers that you can download online. Like there's some that are free, open source, you can get. Others you can purchase with support. Or if you're really interested, you can code your own. Again, it's not that difficult. So there are a lot of options out there, right? Again, this is specific to the scenario or where we need to send like a dynamic or breaking type of news updates, like urgent events out to your end users. Now, I'm going to go to the third topic briefly, security, because in the beginning I did say that there were some nuances with security that may impact the way we architect our custom code. And like someone here mentioned before, there could be issues where bottleneck could be the intrusion detection protocol or the firewall, depending on how many you have in your architecture. But the one thing I'm going to focus on is that it occurred because it came out from modern research. Because nowadays, we've noticed that a lot of the penetrations happen from within the corporate network. So sometimes it could be a disgruntled employee like myself, right, wants to steal something, or it could then social engineering, somebody somehow finds or talks to someone in your company and is able to get in that way, right? So what some security architects recommend is that they say we should, and a lot of .coms do now, is they place sensitive information that they receive from the public in another trusted zone in the network. So this one is not in the corporate network, but actually outside and attached to the DMZ. So if you have a website with identity management features, like people can log in and have a profile on your website, then they would recommend putting that type of personal information in this separate trusted zone. So the only thing to be aware of is that, well, if you want people to be able to get that information, let's say to do a login to check their password or to see their profile, just don't send them through the corporate network to get it, right? Just don't put the API in your corporate network and have them call the service there. Just put it in your other trusted zone and make sure there's firewall rules to allow communication between the DMZ and this trusted zone. That's all. One less step to make things a little faster for the end user and still secure.
Can I just make a comment?
Yeah, sure.
So why not, instead of having the same sort of I guess perimeter, just on another network, go the perimeterless route and make sure your machines and services are hardened.
Yeah, that too. Like, I mean, that they should be doing it, right? Because that's part of the whole internet security standard. There's some, you're referring to that, I don't know what it's called, but they have a whole bunch of documents saying that to harden your server, right, you have to follow these rules and configuring it, like the accounts can only, right, have these permissions, right?
Rules, it's just
Requirement or something.
things should just be common sense.
Yeah.
Guidelines.
Yeah, the guidelines thing. Yeah, we do that actually in my current employer. They harden the servers in the DMZ, make sure. But it's just nothing's perfect, right? If you want extra protection, I guess go this route. Hello? Yeah. Sorry.
From a security perspective, security is one of our concerns. So like we had a major breach in 2011, and then the security was stepped up a lot. And I'm talking about PlayStation services, what we do,
Yeah.
the authentication, e-commerce, etc. I'm talking about sort of big
Just
store,
you're being recorded, right? So be careful.
it's not secret.
Yeah.
Um,
Just in case.
And so one of our major challenges is DDoS, because we get attacked very
Yeah.
often with enormous loads because of the numbers of the gigabit per second. And that's a really
And that's the good point, because really that's the easiest way to attack a system, right? The denial of service and all that. There's really not much you can do, because no matter how much load balancing or how much scaling out you put in, eventually, if they have enough resources, they can overwhelm you, right? So let's say, and I'll talk about that a little bit next. Let me actually go to the next slide, which is a little bit more related to it, what you're suggesting or discussing. It's a very good point. Let's say, okay, so now, as you know, I want to talk a little bit about the hosting options we have, because that can also have a big impact as well. Now, as you know from my research and my experience, because I'm doing the old-fashioned way of having it on-premise and everything, I only have one pipe to the internet, and that was the one that our vendor said had a bandwidth issue, especially with that pipe. And what happened is that we have a 100 megabit pipe that's supposed to be burstable to 1 gigabit, but it wasn't able to burst for whatever reason. Maybe there was traffic from from going to other websites in the same data center that prevented it from doing so. And to demonstrate it, as someone asked before, how did we know it was bandwidth? What that person did was they set their load test to only pull the page with the most graphics on it, basically the largest page, right? Usually the home page, because we have lots of pretty banners and pictures on it because we want to make things look nice. And probably most companies nowadays do that too. So basically, after a small number of concurrent users, say about 1,000, right, we noticed that the bandwidth all got used up.
Didn't the network guys verify that on the routers or the firewall?
Yeah, they checked again, and there wasn't. I think, if I recall correctly, it didn't even get that far into the networks and firewalls because those didn't show too much traffic, but we mostly stayed on the outside, right?
But it could be the internet firewall or the internet router.
Yeah, I guess. You know what, I have to check back on that, but yeah, it could be any of those pieces. I do believe we did some tests before where we checked the firewall traffic and it was pretty high as well, right? But then again, that could be the way we set it up because we only had maybe 2 firewalls in theirs, right? So maybe on the same level, maybe we need to scale out. Who knows? But the way around this, a quick and dirty fix, is the content delivery network, which probably most of you are already familiar with, right? The CDN. So basically, that hosts the static content of your websites out on different points of the internet. So when the user goes to get that that large content, basically they're not directed through your internet pipe. They're just sent to edge servers on the content delivery network.
Like Akamai.
Yeah, like Akamai, basically. Yeah, that's the good example. But what happens? So in that sense, with like talk about the denial of service attack, if you have content delivery network, you can kind of spread it out, right? But I don't think that works in your case, right? Because yeah, yours is interactive, right? That's one thing I found out too. Because even websites that features, let's say just the contact us page, right? Even if the contact us page is hosted on one of those those edge nodes, like Akamai edge nodes, it still has to make the call to write the personal information to your customer relationship management or CRM system in-house. So that still won't stop that load. So next option you have nowadays is cloud, right? Where all the virtualization resourcing done for you. So if you host it in the cloud, then the cloud should naturally allocate the resources to handle this, right? So that's a really nice hosting option. It's the one I prefer. But I guess in your scenario, you cannot, right?
So for the CDN, there are solutions, there are vendors who actually offer protection on the edge too. Instead of just doing caching, for example, they can detect certain attacks.
Yeah, I think Akamai has that too, right?
Yeah, Akamai.
Yeah.
They purchased one company who specializes in this.
Yeah, that's a good point.
One vicious attack is slow lore, which you just send requests, public requests, but very slowly. You just don't make the TCP time out with it, and it will just slow down your attack service, especially if it's thread-based and maybe a bit less secure using asynchronous layer.
Yeah.
But then cloud-wise, the thing is, those attacks, if you get attacked at a level of like 300 gigabit per second,
Yeah.
If you have like auto scaling in the clouds, it's going to cost you a lot.
Yeah. You're going to get.
You can
Yeah.
handle traffic with
Yeah.
this kind of
Yeah. But they.
lose from
Yeah.
this perspective.
True. But they should have the same thing like a content delivery network, that protection, right? Because we don't have a, before we had content delivery network, we had a firewall vendor, right? That even they too, they screened for what they thought was denial of service attacks coming through. So if they noticed that we had a lot of requests for something suspicious activity, say a pattern of a large number of requests from the same IP address or something asking the same thing, then they would flag it and maybe stop it, right? So that we wouldn't get hit. So there's things there, but ultimately, it depends on the attacker too, right?
It's not going to stop DDoS.
Pardon?
It's not going to stop the DDoS.
DDoS. Oh.
Distributed.
Yeah.
You gotta-
Coming from the different sides,
you gotta
exactly.
move out from as close to the attacker's house
Yeah.
and as many industries as possible. Like a reverse problem.
But no matter what, they can still overwhelm you because they too will have, they probably have hacked into several data centers or clouds themselves. So then, right, because DDoS is distributed, right? So eventually,
We typically
It's-
work with botnets, which have like a couple of tens of thousands of machines in
Yeah.
them. And then those vendors, they Akamai, they have lots of machines too.
yeah.
And so yeah, hack their machines, your machines basically, but on the edge. You can't allow traffic to come close to your to the origin.
Yeah, that's the general strategy, which I'll get to next. But it's a good discussion, the DDoS thing, because it is a real challenge, right? How do you architect? It's like there's only so much you can do. Eventually, you will be overwhelmed no matter what, right? So in terms of recommendations, the strategy, like as you just said before, I think is pretty well discerned from all our discussions and the slides here. It's edge computing. Actually, this is a term I stole from Akamai, right? But essentially, it means just trying, again, to keep the users out on the edge, right, or outside of your DMZ. How do we do it tactically? Well, we'll try to use push techniques, which I showed in these slides, and try to keep our other systems decoupled from the websites. So even if the websites go down, the rest of the other systems are not impacted. So how do we do that? The first, I discussed before, the decoupled content delivery pattern, right, for web content management. The next, real-time web communication. Again, and that's only for the cases where we need to have event-driven, like news updates, things like that. And the last is cloud hosting, right? Because the cloud can naturally expand to handle this load. But again, we have the cost trade-off, right? If there's a high number load, you're going to be paying a lot for it. And again, just to reemphasize how the decoupled pattern works, this is a nice diagram. Shows the content flows out from the WCM system, the content manager, to the web server. Try to do it again using Archimate shapes just to show you that the content, what zones it passes through, like from the trusted zone out to the DMZ. Now, for the real-time web, I just want to show you again the sequence diagram, but this time I wanted to show also the trade-off with it, that you have to keep track of state. So there is the overhead of maintaining the connections, and that shows from the first two arrows coming in. But after that, all the updates are just pushed out, so everything flows out. Again, using Archimate just to show from the application side, the information generally flows out. And again, to emphasize the less inbound traffic here using AADL. Last thing, again, I want to talk about is the cloud hosting. It's my personal preference. And again, like you were saying before, in the scenario of like DDoS, where it's distributed, then you could eventually overwhelm your cloud server, or you could be paying a lot of money, right? But I put 4 examples here. EMZ actually itself does not have a cloud, but they have partners that use their products and services in their clouds, right? So they have a lot of, if you search their website, there are a lot of cloud vendors associated with them. Now, Azure and Amazon, they're, as you know, are the biggest cloud vendors out there, so they have the most resources. But the ones I want to point out here is Azure and OpenText. I want to focus on those two for a bit. Because Azure, as you know, is a Microsoft solution, right? And what's Microsoft's recommended WCM system? It's SharePoint, right? And what's SharePoint? It's a page-based system. So this is important. OpenText, again with Vignette, as we discussed before, it's also semi-page-based, semi-decoupled, right? So you're going to have those. So in these two scenarios, you have to have your WCM solution architected so that it may have to handle higher concurrent user load. But because it's in the cloud, it should naturally do that. So it's a nice workaround, right? So even if you have a page-based system, it doesn't mean you still can't support high user load. You may have to look at your hosting options, that's all. And I believe that's it for me. I think we still have plenty of time. We still have like about 15 minutes if you want to talk a bit. Just before we go, I just want to mention that one of the diagrams here was given to me from Andrew Douglas. He used to work at SDL Tridion, but now he's at Ingenix. And my own contact information, in case you want to keep in touch. I hope you're willing to you leave me your contact information as well. I definitely have questions for all of you as well to follow up. So thanks for coming today. So I guess I just want to open up the floor to any discussion or questions you may have. Okay, thank you. Is there any questions or? Oh, okay. Well, thanks for coming. I guess we can break early then. And
I guess I have a couple questions.
Okay,
How
sure.
would you handle something like even base interactivity, like campaign management or something like that? Being able to have like a e-commerce or retail site that has to look at I don't know, just campaigns and the fact that you've got Google search terms and you want to track all of that in your analytics, or even considering something like measuring page render time or something like that. If you had any observations there?
Well, in terms of page render time, there are some well-known tricks already published, which is why I didn't go into them. Like they recommend putting your JavaScript in what do you call it, at the end of the page, right? Or having it load asynchronously. Or when things like images and all that will take longer to load, you probably want to put it on a content delivery network at the bare minimum, not the cloud. As for the features of e-commerce and shopping, again, it depends on the requirement, how you want to do it, right? You just basically have to, it all depends on your implementation. You have to architect and scale out appropriately for those, right? Because you have to make a call to the back-end server, right, in those cases. And I don't think it's one of those features where you will have like a breaking event or something like that, right, where you have to push things out. So you have to make sure your back-end systems scale appropriately.
Did you use any of the page caching, like the stuff that like browser caching and that sort of thing in your performance considerations?
Browser caching, no. Well, we turned that off when we did our load testing, right? Because we really want to check to see how much we could handle. But yeah, browser caching can help. As for page caching and all that, no, we haven't done that yet. So I think it's a good thing to do. I know other vendors have done that. They use things like memcache or whatever.
Is your site over SSL?
No, it's not. It's a good question. No, the one site that we did all the research on is not over SSL. SSL, I guess it has a little more time with the encryption, but I can't see that being a huge impact. It shouldn't be, right?
The initial SSL handshake takes all the time.
Yeah. So like the real-time web, establishing that state, right? But yeah, but after a while, it shouldn't. Right?
Thanks.
Okay. Thank you. Those are very interesting questions and comments. I appreciate that. So.
So in your implementation, what types of activities cause push notifications?
It would be in our particular case. In our particular case, it's more like a update, like breaking news alerts. So let's say if this service is suddenly going to be delayed by let's say a snowstorm or something like that. Then
So they're all sourced from an internal author.
Yeah, all sourced from an internal author. Yeah. So, okay, you know what, I'll hold this. Does anyone else have anything they want to ask or add to the discussion?
So are you still load testing?
Pardon?
Are you still load testing the solution you've been discussing?
Still load testing it?
Yeah.
Yeah, we are doing some tests now. It's ongoing, so so I don't have all the information as of yet. Right? It's being researched by an outside vendor right now. So. Again, a lot of the things I discussed here are just, again, are best practices also used by other vendors as well. Right? So they've presumably or hopefully have tested it. Well, the recording will have some interesting background noise that way. Oh, okay.
Okay, thank you.
Thank you. Thank you for coming. Nice meeting you all. Thank you. Thank you very much.